Once again, welcome to the Fundamentals and Methods of Innovation Convergence course here at Digist. As I mentioned, this is a very special course, and as I'll describe, hopefully one of the most important courses because innovation is very critical. Right now, we are in the midst, of course, worldwide in the COVID crisis. That's one reason why we're doing the course online. And ultimately, the only solution to this crisis will be innovation, whether it be in vaccines, in public health measures, in policies, and what individuals do to keep themselves safe. Everything will depend on innovation. And in fact, as many of you know, South Korea has done not so bad with this crisis. And some of that is due, of course, to innovative approaches, innovative policies, et cetera, that have helped South Korea manage this better than some other countries. That doesn't mean everything is perfect. And in fact, innovation always has not always the successful stories, and that's the definition of innovation, with some failures and testing and so forth and successes. But innovation is very critical. So this may very well be one of the most important courses you take for your career, whether it be scientific, business, or whatever. Innovation is a critical component of success. And in this course, we will be going through a whole spectrum of all the aspects of innovation. It is a true convergence course about the nature of innovation, the history of innovation, how it's related to biology, and geopolitics, to government policy, to intellectual property, to the sociology, the business aspects of innovation. So this is a truly integrative course. Another aspect of this course that is very important for innovation, and is an innovation in itself, will be that we will be integrating science and art. And true innovation, as we will talk about, is not just a product or a technology or a scientific idea. It's the integration with the full spectrum, the full toolkit of our human culture to make impactful change in the world and make the world a better place. So the course will actually be two parts. One is going to be about innovation per se, and the other one will be about integrating science and art as a true convergence course. On a practical matter, as I emphasized, the attendance will be taken by entering your name into the Zoom chat room. So please enter your name and number if you have not done so already. We'll go over some other practical aspects of the course, the grading, the assignments, and so forth later on during this lecture. The other thing is, as I mentioned, we will be integrating with Google Calendar, and I'll show a little bit of that a little bit later. So if you have it, please make sure you send me your Gmail address so we can register that. It will be a smoother integration with the Google Calendar and other IT aspects of how we communicate and share ideas and share files and so forth. And then also related to that, most of you have connected to me on Kakao Talk. So please connect with me if you haven't on Kakao Talk, and I will create the Kakao Talk group so we can do some instant messaging that might be related to the class, the Zoom link for the lectures, and so forth. So any questions? Any concerns, suggestions before we start? 질문 있습니까? 오케이, 시작하겠습니다. And I will share the screen now. Okay, the title of this course is Fundamentals and Methods of Innovation, Unity of Science and Art. This is the HL 270 a Convergence seminar. And our first lecture today will be an overview of innovation. So this will be the introduction to the whole topic. And the second part of this lecture will be a specific focus on the unity of science and art. And the primary text we'll be using for that, which is the novel Waves, which I'll be introducing to you in the second half of this lecture. So I am a visiting professor at Digist, but I also have an academic appointment at the Soulbridge International School of Business. I work with several startups, CT Cells, a cancer treatment novel platform for treating cancer based on NK killer cells, natural killer cells. I'm chief marketing officer at a digital healthcare company called Eatware, a venture partner at a venture firm called the Yozma Group that works between Israel and Korea. I am an advisor of the Crest Digital Health Cluster in Malaysia, and I have some other appointments in Australia, and I work with Labo Design University in Italy. So that's my background, and as you can see, it's fairly broad. It goes to science, it goes to business, and aspects of the digital healthcare and cancer treatment and so forth. So I bring together a lot of different areas, and that's going to be important in innovation. Another thing from this opening slide that you should notice is my email address. All of you already know that. I'm also on LinkedIn, and I sent invitations to all of you, so feel free to connect on LinkedIn as well. So this course has two parts. Part one is the fundamentals, history, methods, and applications of innovation. And this first part has two halves, part 1-1 and part 1-2. And in the part 1-1, indicated on this slide, we will be going over the fundamentals of innovation and the history of innovation. So for example, today's lecture is what is innovation? And we'll be going over an overview of creativity and innovation, the many different kinds of innovation. And then we will proceed to history of innovation, innovation, and culture. The second part of the course, or I should say part 1-2, is the methods and applications. So we'll be talking about the neurobiology, how the mind comes up with creative ideas of learning, of creativity, and then we'll talk about specific innovation in universities, in companies, and then we'll be talking about innovation methods and specific methods, innovation measurement and specific methods of innovation. So that falls under the category of methods of innovation. And then we'll look at the broader picture of innovation, innovation in society. So how do civilizations rise? How do they fall? What is the role of innovation in history in this way? The economics and geopolitics of innovation, government policy and innovation with an emphasis on intellectual property. And finally, we'll talk about the future of innovation. So as you can see, this is a broad overview of many aspects of innovation, both the background as well as the applications. The second part of the course, and when I mean second, it's actually part of the course throughout, but the second half of our lectures each week will be on the unity of science and art. And we'll be using literature, in particular a book called Waves, as a window, as a platform to understand this unity of science and art. Because as I mentioned, and in the article that I sent you as a background for today's lecture, bridging science and art, bridging the scientific world with the humanistic world is extremely important for innovation, not just in coming up with new ideas and seeing things in new ways, but also in applying them and making them into reality. So we will be talking, as I mentioned, in each lecture, we'll have the topics that I just reviewed before. For example, today will be an overview of creativity and innovation. Next week will be adaptation and evolution, innovation and biology. And the second half of each lecture will be about literature. And we'll go through in the first lecture today an introduction to the novel Waves. And I sent you the instructions on how to get that through Amazon. And next week, we'll be reviewing Goethe's Faust. You don't have to read Goethe's Faust. It's a major work of literature that is one of the first global literature, and it's also an integration of science and art and culture, a very monumental work. And so we'll review that. The reason being is that Waves is a 21st century version of the Faust legend. And then in the third week, we'll talk about innovation in the ancient world, Leonardo da Vinci, Michelangelo, and the Renaissance. In other words, some of the history of innovation. And then in the second half of that lecture, we will discuss the first three chapters, the first triplet, 1, 2, and 3 of Waves. And then again, we go the next week to an innovation topic. In the fourth week, it will be the history of innovation in Korea. And then we go to the second triplet, namely chapters 4, 5, and 6 in Waves. And these are the subtitles to those chapters. So here you can see we go through each chapter. And so the weekly assignments will be, as I'll talk about in more detail, a short one paragraph assignment, or 1 or 2 paragraphs about the reading, and then we will go through that. I'll ask a question, and that will be posted on the Google Calendar and sent to you by email and Kakao Talk, so everyone will know exactly what to do. So that is the overall scope and the overall schedule of this course. It's a very intense course. We'll be going through a lot of material, but I think by the end of it, this will be quite impactful, and hopefully you'll have the mindset and the toolkit to do really innovative work in your careers, both in academic and then careers after school in the future. So let's begin with a question. So I'd like you to answer. Obviously, we have many people in the class, 25 participants, but the question, so we don't all have to answer, but give this some thought. What is innovation? So who would like to answer that? You can raise your hand in the Zoom window. Anybody want to venture a guess? What is innovation? 혁신 뭐예요? So 대답해 주세요. Okay, some of you are typing in the chat room. Something brilliant, something new. Any other ideas? So Choi Dae-gun said something brilliant. Park Shi-young said something new. Don't be afraid. Just give me your thoughts. What is innovation? So Su Yun-young said new ideas, innovation. Any other thoughts? Hyun-tae Hyun said, I think innovation begins with a challenge. Okay, so a lot of people say a lot of things about innovation, but the common theme is something new, something brilliant. These are all very positive things. Innovation, it's interesting because when people give presentations for a startup, they say, oh, we are innovative, and not necessarily knowing what that means. And the purpose of today's lecture will be to really understand what exactly is meant by innovation. Another person wrote, Taegun wrote, different from the old. So one of the problems is many people associate innovation with a new idea or creative idea, and that is only partially true. And we will describe what I mean by that. So here are some textbook definitions of innovation from the business literature, because innovation is very important in business, although not exclusively so. So in 1990, Howell and Higgins described innovation as the process by which entrepreneurs convert opportunities into marketable ideas. Now, so it's more than just a new idea. They talk about a process, and they talk about entrepreneurs and how they convert it into marketable ideas. So an idea alone, a new idea, is not innovation because it's not really in the market. It's not a process. It's just a new idea. I don't exactly like this definition because it's focused too much on business, but I think it gets a little bit better idea what we mean by innovation. So the process by which entrepreneurs convert opportunities into marketable ideas. And of course, scientists, artists, other people also innovate. So it's not just entrepreneurs and not just business. And then Peter Drucker, who some may regard as one of the top business gurus in the world, in 1985, described innovation as the specific instrument of entrepreneurs, again, focusing on entrepreneurs, the means by which they exploit change as an opportunity for a different business or a different service. And again, I think this is too limited. Even though he's a great business guru, etc., I think innovation is more broader than what he describes there. A better definition is Luque and Katz. Innovation is generally understood as the successful introduction of a new thing or method. And so that's a very important concept, successful introduction. In other words, a new idea alone, if it's not successfully introduced, is not innovation. So let me give you a question, another question. All of you are familiar with Leonardo da Vinci. Leonardo da Vinci in Florence, in the Florence Renaissance, a brilliant scientist and artist. Would you say that he was one of the most innovative people in history? Let me know your answers. You can type them in the Zoom room, or you can just raise your hand and suggest your answer. So, do you think Leonardo da Vinci was one of the most innovative people in history? Anyone care to answer? 대답해 주세요. So Han Tae-hyun says yes. Any other answers? Taegun says yes. Let's have more answers. Lee Yoon-ji, Chae-chok, Lee Hae-in, Chung Yu-na, Chang Seung-hae, Se Jong-om. So everybody is saying yes. So I think you can tell a little bit about my style. I like to look at things a little differently. Most people would say that Leonardo da Vinci was extremely innovative, and so that's what your answers are. But my style is often to give a question that may seem obvious, but actually has a different answer. And one could say that Leonardo da Vinci was not very innovative. Instead, what you could say, he was very creative, or he was very inventive. What I mean to say is he had all sorts of designs for flying machines, for robots, for military machines, tremendous creativity and inventiveness. But very few, almost none of his inventions became successfully realized. They did not become a part of the reality of his time. In other words, he had all these great, brilliant ideas, but he actually didn't make them work. And therefore, by that definition, which we will develop a little bit further, he was not very innovative. So he was creative, perhaps one of the most creative persons in the world, but also, and also very inventive, but he was not, according to this definition, innovative. And so in my estimation, I would not regard him as one of the most innovative persons. Of course, he did have some innovations. He had some paintings, the Mona Lisa, etc., which have indeed changed art and changed the world. But many of his inventions were not realized. If you contrast that, for example, with Bill Gates, perhaps a more boring person, nerd and a geek, etc., and not necessarily brilliant new ideas. The Microsoft operating system was not necessarily the only one or the most unique one, but he was able to, along with others working with him, make software for personal computers widely available and had those ideas actually implemented worldwide. So right now, I'm using a Windows computer. Many of you may be doing the same. And of course, since the 1980s, that has had a tremendous impact, transformatory impact on the world. So Bill Gates might be considered more innovative, more impactful than Leonardo da Vinci, although one could say that Bill Gates was not as creative or as inventive. So this is a very important concept. Another way to think of it is that innovation is a combination of invention and, in this diagram, commercialization. Not exactly the right term. I would call that implementation. Commercialization is making it into the market. And so innovation is at the intersection of not just the new idea, like what is possible with technology, what you learn a lot at Digist, what you learn in university, what people do in the research labs at a science and technology university like Digist is this left-hand side, what is possible with technology. But what is also important is what is viable in the marketplace. So Leonardo da Vinci's inventions were not viable, were not possible, and maybe not desirable to users. There has to be a human element as well to these technologies and to these ideas. They have to intersect with how people use technology, how the market works. And so invention that is separate from the market, separate from reality, will not become innovation. So we can contrast creativity, which is the thinking of new things, with innovation, which is the doing of new things. So this is very important. Most of you were, when I asked you the original question, what is innovation? You answered essentially not that question, but you answered the question, what is creativity? Or what is invention? It's thinking up new things. And innovation is making them real or is doing new things. So a large part of this course will be exploring how we make these new ideas actually into reality. So another aspect of innovation, and another answer to the question, what is innovation, is there are actually many different kinds of innovation. We talked about invention versus innovation, but there's also product innovation, process innovation. There is business model innovation, which many people have been talking about. Some people may have heard of disruptive innovation, so that needs to be contrasted with incremental innovation. Then there is the concept of closed innovation versus open innovation. And some of you may not have heard about this, but there's traditional versus reverse innovation. And finally, and very importantly, is organizational innovation. How can groups of people, how can organizations, how can companies organize to foster and enable innovation? And all of these topics we're going to introduce today and also develop in more detail during the course. So let's start with the distinction between invention also known as creativity, and contrast that and compare that with innovation. So this is a very important diagram. It shows you that invention is the beginning and is very important, although not always essential for innovation, which we'll describe. But one characteristic of invention is a confluence or convergence of science and art. If you are just focused only on the science and only on the technical aspects and don't see the broader issues, your inventions are likely to be limited. So you need to understand also the humanistic aspect of technology and of this science. So that's where science and art come together to foster invention. And then successive degrees of development or applied research lead to marketing of that innovation or making that innovation commercializable or into the market or into reality. Or if you're a scientist and not a business person, making your scientific idea become the standard theory or the standard accepted science in the scientific community. So invention, the combination of science and art, leads to innovation. So my definition of invention and innovation is as follows. Invention refers to the discovery or creation of a new idea. That's what most of you had answered when I asked, what is innovation? So, and this is one reason why Leonardo da Vinci was so inventive, is invention is usually the work of an individual, one person. And another interesting aspect of invention is because it's a new idea, it is by definition outside of reality. And of course, when it comes to creative people and creativity, sometimes there's an element of craziness. And that has been noted in many creative people that have some element of being outside of reality. This is all in contrast, almost the opposite with innovation. Innovation refers to the combination of inventions or the institution of processes around the core invention that make it real. And innovation is typically the work of groups, not individuals, since a variety of capabilities and abilities and resources are required. And this is why this course is so broad, because if I just give a course on how to come up with a new idea, that would not be an innovation course. Instead, we have to have a course that talks about all the different capabilities, resources, and processes around making these inventive ideas or combinations of ideas into reality. Also, it should be interesting interesting to note that people often talk about a startup, an entrepreneur, and how the brilliant entrepreneur creates an innovation, and that is almost never the case. Usually true innovation is that entrepreneur working with another entrepreneur. So if you look at the history of companies such as Apple with Steve Jobs and Steve Wozniak, and Microsoft, I mentioned Bill Gates, but also Steve Ballmer. And then Google was a pair of entrepreneurs. Almost all of these innovations was at least two people, and certainly a bigger group, in order to realize them, because it's very difficult for one person to have all the skills to do true innovation. So it's a group process. And finally, innovation, by definition, takes new ideas into reality. So invention is outside of reality, innovation is going into reality. So you can't be totally crazy. You can't be wild and totally separate from what is actually in real life and what is in the market. And so there's an element of realism to innovation. So these three steps are invention, innovation, and diffusion. And we can talk about the whole process, of course, as being innovation. Diffusion meaning bringing that idea to a wider audience. So let's look at a case study. This is an example of a drug company called Pfizer and a product that they had, which was called Exubera. This was about 12 years ago or so. And this product, Exubera, was an inhaled, breathing in form of insulin for diabetics. Patients with diabetes mellitus, require insulin, some patients. And typically, as many of you know, that insulin has to be injected. It is a protein, and that protein cannot be taken orally, cannot be eaten as a pill, because it will be broken down to its constituent amino acids in the stomach acid. So you can't eat insulin, so you have to inject insulin. Of course, that process is socially embarrassing as well as painful. So there's been a lot of interest in ways to deliver insulin without doing the injection. So one way is the inhaled method, where you breathe through this tube and you breathe in the insulin. Very sophisticated chemistry, biochemical engineering, and so forth was done to make this possible. But it turned out to be a failure. Pfizer had a nearly $3 billion loss in US dollars, and basically gave up on the project after they did the initial marketing. And that's because no patients really wanted to use this, which is strange. You know, who wants to inject a needle? It's especially difficult for children. But this bulky apparatus is not so easy to use. It's difficult to carry around. It looks embarrassing if you do it in public. And interestingly enough, it's associated with a similar device that people have used to smoke marijuana. And so there's a social stigma to that. It just looks weird. And these sort of emotional human reaction basically meant that this device was not adopted by the market. It was not adopted by patients. And so you can have the best science, but if you don't see the humanistic aspect and how this actually works in the market and how patients would use it, you don't have a successful innovation. So this was a brilliant idea, a new idea certainly, but it did not become an innovation, and nobody knows about it now until I give this lecture. And this is related to the concept that doctors do not treat disease. Good doctors also look at the whole patient. They treat patients who have diseases. And so good innovators, if they want to have an impact and solve problems, just like doctors want to cure patients, they have to think not just about the science and the technology. They need to think about the humanistic aspect to enable that market availability. So let's look at another example. This is the so-called videotape wars of the 1980s. Some of you may have heard about it. This is a very classic case in the business school education. And it was VHS, which was JVC and Panasonic, versus Betamax, which was Sony. Many of you are very young, so you may not have a lot of experience with these, but these were these magnetic tapes that were used for video. And it turned out the Betamax is on the top, the VHS is on the bottom. And for those who have used videotapes like this, you'll recognize that this one, the longer one, the VHS, is the one that everybody ended up using. We don't use it a lot now, of course, because it's obsolete. But at that time, VHS became the standard. It was the innovation that beat the Sony Betamax. Now, what was interesting is that the Sony Betamax was the superior or better technology. So a lot of scientists and many people at Digist and other research institutions say, I want to do the best science, and have the best result, and all of you are students at this university and you took your exam to get into the university, so you had the best exam, means I get into the best university. And so that's that mindset of the best technology, etc. So how come the best technology did not become the real technology or did not succeed? There are many complex reasons for that. As I mentioned, this was the format war of the 70s and 80s. And Betamax was superior. It had higher resolution. It had slightly superior sound. It had a more stable image and Sony associated quality. But some aspects were very critical to making it more successful. So people want to see content, they want to see movies. VHS, which was licensed by GVC as an open technology, had two consequences. One, many companies could make it and could put movies on and different content. So there was a lot more choice of content, and it was also lower cost. And one technical aspect, they had longer recording time. So the less superior technology had some key aspects related to how it can get out into the market, and the value to the consumer was greater. These other technological superiority was valuable to the engineers, but in order to make an innovation, it's not just what's valuable to the engineers and what they think is good, it is what the customer thinks is good. And so innovation has a very close connection to marketing. So this is a graph of the adoption of the different video technologies over time. You can guess that blue was VHS and this darker color was Sony Betamax, so that eventually it was not used at all. It was another classic case of complete success over one technology over another, and not necessarily due to the technical factors, but due to social factors, human factors, market factors. So of course, bad technology doesn't mean it's going to be in the market, although it should be noted that the Microsoft operating system was not necessarily as good as some competing operating systems, but we'll talk about that later. So, but there has to be some basic level of quality. But quality alone, from a technical perspective, is not sufficient for innovation. So here's another question, a little bit related. We talked about invention and innovation. Which is more important? Is it really critical to have a new idea in invention, or is innovation more important? The question doesn't have a right or wrong answer. What do you think? You can answer in the chat room. Which is more important, invention or innovation? So Han Tae-hyun, Lee Hae-in, Lee Yoon-ji, Chae-chok, Choi Ji-yu, Chang Seung-hae, Tong Yu-na, Park Si-young, Kim Min-young, Choi Dae-gun. What do you think? Which is more important, invention or innovation? So we have some answers, innovation. So let's go to some case studies. So somebody says, I think invention is more important because innovation is followed by invention. So I like that answer. That's Han Tae-hyun. Because actually, I'm going to give an example of an innovation where there was no invention. So even though I said invention comes before innovation, there is such a thing as innovation without invention. So that you might say, oh, that's strange. How is that possible? Well, let's look at the example of the IBM PC, the IBM personal computer. This is a very old computer, 1982. Most of you may not have ever seen it except in pictures like this. But this was a remarkable uh, innovation. It created the personal computer revolution, and everybody is using personal computers now. And of course, there were Apple computers, but this was really the one that went much bigger. Apple remained more of a niche product. And I like to say that much of the success of South Korea is because of this product. In other words, the fact that we have nice cafes, we have nice roads, and we're an advanced, developed economy, South Korea, is because of this product. So you might say, well, why is that the case? South Koreans made this economy. Well, this product markedly increased the demand for memory chips. And of course, Samsung and other Korean companies entered that market for memory chips. And that was one of the reasons to help build the economy in the 1980s, 1990s to what it is now. So the IBM PC has helped Korea to become what it is. So this is a very impactful product. That's what I mean to say. And I'm not saying that other reasons why Korea is successful. But if you look at it, the fact that this computer created all these markets and made such a big impact and such a big demand for memory chips and so forth, definitely impacted Korea and is impacting your life today. So that's a big innovation. It's a new thing that changed the world. But it's a new thing that did not have any invention. Why do I say that? Because Apple was making personal computer, not the Mac, but it was before the Apple II. And there were some other personal computer companies, etc. And IBM wanted to enter this market. So the IBM top management created a team to create this, develop this PC, and they had explicit instructions. They said, no invention, absolutely no invention. Don't make anything new. Instead, use established products, put them together, and then do the PC. They didn't want IBM microprocessor. They didn't want IBM software. They didn't want these other things, serial ports and parallel ports and floppy drives and all these sorts of things. They said, just bring it all together, make a nice design around it, and pull it together and and put it out on the market. Those were the explicit instructions. And it was actually important for IBM because IBM has a history of coming up with new inventions. The hard drive, for example, and other technologies were new ideas, new inventions started at IBM. But with the PC, they said no invention, because they had to work very quickly and so forth. So as you know, the IBM PC has an Intel microprocessor and also a Microsoft operating system and many other components that were taken from other places. So they brought them all together. So this was tremendous innovation, but no invention. It ended up being Man of the Year in Time magazine. And as I said, impacts today and worldwide, including South Korea. So this is an example of innovation with no invention. Now, is innovation without invention always good? So here's another example of innovation, the SUV. The SUV in the 1980s and the 1990s was an innovation, but there really was no invention. It was a little bit like the IBM PC. They basically took trucks and refashioned them as personal vehicle. They applied sophisticated marketing, bigger is better. Inexpensive gasoline facilitated this process in the late 1980s, leveraging a suburban culture. And so this wasn't really an inventive product like Tesla, electric vehicles, or other sorts of inventions. It was an innovation that brought together established components. So as you know, General Motors and Chrysler as well, and many companies that just focused on SUVs had trouble sustaining that model. And Tesla is moving beyond. And these legacy companies with the established vehicles and the SUV strategy, they actually went bankrupt. And one of the reasons for this was not just the financial crisis, but the failure to innovate and the lack of new car and new technology development. So innovation without invention is not always good. Let's move on to another concept of innovation, the difference between product innovation and process innovation. This is a famous professor, James Utterbach, measuring the dynamics of innovation. So innovation, when you're developing a product, is not static, but changes over time. For example, in the early stages of a product, we have more product innovation. And in the later stages, we have what we call process innovation. And then eventually, with product and process innovation, we get a dominant design emerging. So we have a fluid phase, a transitional phase, and a specific phase. And so examples of this process innovation are assembly line, such as the Model T automobile with Henry Ford, that enabled workers to work more efficiently and more productively by sequencing operations, minimum distances between the worker and their tools and the product, and regularizing, systematizing that work. Another example of process innovation, which Samsung and Taiwanese and Singaporean and Chinese companies are fighting, is ultraviolet lithography for even smaller and smaller, dense or higher and higher densities on smaller and smaller chips. So let's talk about a third case study, the SaeHan and the Rio, which are Korean-American companies, and the iPod. So the first major MP3 player that entered the market was essentially a Korean product. It was called the Rio. So this was from SaeHan Information Systems with Lee Chung-moon, and he created this device called the Rio. And this was a perfect example of product innovation. So the first MP3 player was this Rio. But as you know, the dominant design, the MP3 player that dominated the market, was not the first one, the Rio, but was the Apple iPod. And most people think that the design aspect was very important, the simplicity and the ease of use, but probably the key element that made the iPod prevail over the Rio, the Korean Rio, was process innovation, namely the creation of iTunes, which is not a device, but it was a process, it was a business model that enabled users to easily get their MP3s and play them. So the process innovation was the key step in establishing the iPod as the dominant design. We call that also business model innovation. Another concept of innovation that we will talk about is disruptive versus incremental innovation. You'll hear many startups give their presentations to venture firms and they say, our product is disruptive. And they usually have no idea what that means. Disruptive just sounds good and they say, well, we're disruptive. But what is disruptive innovation? It's a very specific concept developed by the late Harvard Business School professor Clayton Christensen. This is one of his books, The Innovator's Dilemma. And the concept of disruptive innovation is illustrated in this diagram. On the horizontal axis, we have time, and on the vertical axis, we have performance of a particular product or process, whatever. And if we look at the incumbents are the established companies, the established product. They improve over time, and they are usually better than what the customer needs or expects. So the customer needs is the dotted line, and these are the incumbents. And the sustaining or incremental innovation is beyond what the customer needs. And then another technology comes, which we call a disruptive innovation, that is lower cost or a completely new market that is lower in performance. And this lower in performance is not what customers need, or I should say it doesn't reach what customers need, so nobody likes it and it's not very good. But this disruptive innovation is also improving. And then suddenly at the point where this disruptive innovation meets the customer needs, then the incumbents who are very high performance get disrupted and replaced by this lower cost innovation, this less performance innovation. So this is extremely important. All of you got into Digis because you did very well on those exams. And you did very well on those exams because you had the mindset that I will do better on the exam than the other students, and I'll be very, everything will be perfect, and I'll continuously improve. And that's the mindset of this sustaining incremental innovation. You don't go and say, I'm going to be great because I want to be less performance. I want to get into Digits by getting a low score on the exam. That doesn't make sense, right? So this disruptive innovation is very strange mindset, but it's very common. And so it's very unnatural for people like you, for everybody who wants to do better. You want to do the absolute best work and have the best quality and so forth, but actually you get replaced by something that's lower quality. It sounds like it's not fair, but that happens all the time, and that's disruptive innovation. So let's give an example. The vacuum tube versus the transistor. Everybody knows that transistors are the main switching circuit in electronics, whether it's a smartphone, a radio, a television, a computer monitor, or whatever it is, they're transistors. But vacuum tubes, which are also switching circuits or switching circuit elements, have higher superiority, higher performance than transistors. If you looked at audio equipment, very high-end audio equipment, they have vacuum tubes. And so you see here superior sound quality and many advantages to vacuum tubes. And you see transistors, they're lower cost, smaller than tubes, and they have many disadvantages. But transistors are the ones that everybody uses. Why? Because they are lower cost. If you were to have a smartphone made of vacuum tubes, it would probably cost $50 million or something. It would be the size of all of Daegu. So the transistor, which has certain lesser performance characteristics, but it's good enough for basic switching, becomes the standard in all of these circuits. So the transistor disrupted the vacuum tube. So if you're a vacuum tube company and you had the highest quality, the highest performance, but somebody wants to make a computer or a smartphone, they don't need that. In fact, it's not possible using your high-end equipment. They will choose a transistor. So that's one example. So in the history, we've had many disruptive innovations. So the transistor is here. That's an example of a product innovation. The microprocessor, endoscopic surgery, personal computers we described. And then there are also processes such as discount department stores, catalog retailing, Amazon, process innovation that are also disruptive. So is Uber or ride-sharing services a disruptive technology? Many people say it's a disruptive technology because it replaces taxis, but according to the theory, it's not exactly a disruptive technology. For one thing, Uber was launched in a well-served taxi market. The customers already had the habit of hiring rides. The disruptive innovations occur in low-end or new market footholds. So it was this going into an established market, but it was an outlier because it provided a better service. It was an example of a incremental innovation that ended up disrupting the structure of the market. So in the technical terms, Uber is sometimes called disruptive, but it doesn't fit into this model of low cost and low new market. So a few more points about innovation, and then we'll take a break. Another distinction is between closed innovation and open innovation. So another famous business school professor, Henry Cheesebrough, was a developer in the last 2 decades of open innovation. And in closed innovation, which is the traditional model of innovation in companies and many people and many organizations. You do all the research projects inside the organization, and the boundary of the company is very strict, and you do everything in there, and eventually some of those ideas come out and enter the market. So you have the research phase and the development phase, and we call this the innovation funnel. Open innovation, in contrast, is more complex, and the boundary of the firm is more porous, or you can go back and forth. And you have research projects that might spin out, research projects that come in from other partners or working with other universities, not just your research lab. And then you might create a spin out. You might do some joint ventures working with other companies. You might get a spin in, acquire a company, put those together, and you get some products coming out that are not just through the funnel, but in other ways. So you work with many groups outside the company or outside the lab to create open innovation. So if we compare closed and open innovation, closed innovation, everybody works for us. We profit, from the R&D, we have to develop everything. We have to go to the market first. We create the most and best ideas. We will win, we control all our IP. If we look at open innovation, we work with smart people outside the company. We work with external R&D. We don't have to do all the research. Perhaps building a better business model is more important than just getting to the market first. We make use of internal and external ideas, and we have more creative ways of using intellectual property. So closed innovation, open innovation. But in reality, open innovation is not new. One of the first original open innovators was ancient Rome. And all of you are familiar from history of the Roman Empire, which spanned all the way from not just the Italian peninsula, but almost all of Europe, from Spain on the west to Scotland on the north, all the way to Asia Minor, Anatolia, Middle East on the east, and North Africa in the south. So all of the Western world was essentially the Roman Empire. How did they get to that type of dominance? A key element was that they were an open innovation society that allowed to create a lot of innovations. Some of those innovations we use today here in Korea. Korea has great buildings, great infrastructure, high rises and all that, the Lotte, Seoul Tower and so forth. These are all made with concrete. Well, the Romans innovated concrete. They also innovated newspapers, social welfare, bound books, roads. The Roman roads are famous in Europe, some of them still in use. Arches, as you can see in this picture, the calendar that we use today. And then one very important innovation was Roman law, which still has its effect on many countries in Europe as well as around the world. And that Roman law had a very interesting, distinct characteristic. They had a specific part of the law that was called the Latin right. It was the ability of non-Romans to become citizens of Rome. The other cities in Italy, there were many of them at the time when everybody was coming together, did not have this possibility. They remained closed innovation, whereas Rome was different than the others because it had in its legal structure the ability to open innovate. So many people with all different ideas from all around came to Rome and brought their ideas, and that was possible. They were not prevented, they were not persecuted and so forth. They were allowed to essentially live in Rome. And all that open innovation led to the strength of Rome as an empire, militarily and in other ways as well. And so Rome was the original open innovator. Now, we also have traditional innovation, which is innovation going from the developed world to less developed countries. But increasingly important is the concept of reverse innovation, where innovation in less developed countries, which are limited by resources, Africa, rural Asia, etc., can move into more developed world economies. And there's a close link between reverse innovation and disruptive innovation. So if you think of the advanced economies, where there's lots of money, the low-cost alternatives don't have much intensity of value, whereas in the developing countries where low-cost alternatives have to be developed, those can come up and then, of course, improve that they meet the needs of the customer, both in those less developed countries as well as in the more developed countries. So there's a close link between reverse innovation and disruptive innovation. And then finally, we have organizational innovation. In other words, how can we innovate around innovation? This is another Harvard Business School professor, Gary Pisano, who wrote an influential book on biotech called Science Business. And biotech was a very unusual business at that time. This was actually in the 1990s, but some of the concepts are still relevant. And one of the observations from the book is that technology has an important influence on organization. So right now we're organized, in other words, we have corporations and we have startups around organizational structures that were determined by technologies that are 150 years old. So two technologies in particular, the railway, rail transport, and telegraph enabled the modern corporation as we know it. So the rail system allowed for centralized production in factories where you bring all the resources together, such as Detroit and Henry Ford and the assembly line. And then the telegraph enabled centralized management in the headquarters, so then they can control all of these things. So that centralization was enabled by rail technology and by telegraph communication technology. Now, interestingly enough, we have technologies such as 3D printing, on-demand manufacturing, micro-manufacturing. We have instant messaging, communication with Zoom, all these things where people don't even need to come to the office or the classroom. Different technologies that may create, in fact, different organizational structures. So your dream might be to create a startup and make that startup do an IPO and you have a company, but you're talking about organizational structures that are hundreds of years old, or a couple hundred years old. And maybe in 10 years, this startup and this concept may be obsolete. There may be other organizational structures that fit with open innovation, for example, and the concept of science in business that might prevail. So how do we may need to look at the actual, how human beings are organized. And the COVID crisis is accelerating some of these changes to organize people to innovate even more. So my question again is, what is innovation? I hope I've convinced you that innovation is not just a new idea. It's not just a brilliant idea. It's not just a creative person, but innovation has many dimensions and is fundamentally new ideas or combinations of old ideas in new ways that become reality, that impact the market, that change the world. If you don't implement the new idea, it is not innovation. So if you go up and you say, I have a new idea and I'm innovative, the only criteria for innovation is if your new idea has become a reality for many others. That is what innovation is. So we'll take a break here, and you can put any questions in the chat room. I will pause the recording and we will continue. It's now 10 after 4. We will start again at 4:20 p.m. in 10 minutes. 10 minutes we'll start.